On this page of notes, we're going to talk about electrical ground. Now, I added this page of notes into this unit because I've discovered over the years most students come into electricity and magnetism with really little to no background in electricity or electronics, and that's fine. I found it helpful to explain a little bit about what electrical ground means and how grounding a conductor applies to what we know already. So just for completeness, even though we're not going to be using volts or voltage right now, just make a note that ground is always referenced as 0 volts. So just get that in your notes. Now, as it says here, if a conductor is grounded, right, what this means is that the conductor is connected to an infinite source of electrons, and that infinite source of electrons can actually be the actual ground, the earth, so that's where the name came from. Now, as it also says here, it turns out that ground will also act as an infinite well of electrons that electrons can flow to. And what does all this flowing to and from, electrons flowing to and from what we're calling electrical ground mean? Well, in our notes following this, we are going to talk about how it is conductors can get charged. But for right now, let's just assume we have a chunk of metal, initially neutral, and we were able to scrape off some electrons. So it has a net positive charge and it's just sitting there by itself. When we take a wire and solder a wire to that chunk of net positively charged metal, and we stick that wire into the ground, we have now grounded the conductor. And notice the symbol. So that symbol, this symbol here, kind of an upside down triangle, that is the electronics symbol for electrical ground. And of course, as we said, let's get that reference is 0 volts. Again, we'll talk more about voltage later, but for completeness. For us right now, what electrical ground means is that we have an infinite supply of electrons to completely neutralize that positively charged object. So all of those positives, protons that are sitting there and giving a net positive charge to this chunk of metal, when connected to ground, ground will have electrons flow up, as many as needed, to completely neutralize the object. So that is the most important thing for us. So please make sure you get this into your notes, that ground neutralizes any charged object. Ground is the great neutralizer for us. And we can see here it's not just pulling electrons from the Earth, we can also push electrons to the Earth. So if we have a chunk of metal that has excess electrons, and again, stay tuned, our next bit of notes will explain how that happens. But if we have extra electrons and we solder a wire, stick it into the ground, those electrons will flow, as many as needed, until the object itself is neutral. Now, what if we stick it into a section of the ground, or we think we have it stuck all the way into the ground, but not quite, where the object itself is not neutralized? Well, that would be a bad ground. In other words, in the electronics language, we might say, oh, you're floating your circuit. It's not grounded. If your circuit floats or has an insufficient ground, and I think it's grounded, what that means is you have a dangerous situation, because if a conductor that's charged and it's insufficiently grounded to where you think it's neutralized, I think I've brought up all the electrons I need to neutralize it, but you haven't, and then you touch it while it's still charged, well, that can be very dangerous depending on the electronics that we're working with. So I realize that will make more sense, and we'll continue to use electrical ground as we go through the course, but I found it helpful to kind of plant the seed, get the notion started right here, and it makes moving on and talking about the movement of electrons much better even in this chapter.